Hello children. Now we are going to discuss D and F block elements oxidation state. First D block element oxidation states. Main oxidation states of D block element is +2. What is the reason behind that? From scandium, if you check that all are having 2 electron in their s orbital, most of the cases, except chromium and copper, we will see 4s1 it is there, but most of the cases we see that they are having 2 electron in the s orbital. Therefore, if it will lose 2 electron, it will definitely gain more stable state. Therefore, they have a general tendency to release these 2 electrons and to become di-positive ions. Therefore, maximum means most stable oxidation state is +2. Now, if we check for the, suppose I am telling for the chromium, then what will happen, as chromium is having the electronic configuration 4s1 and 5d 3d5, then what will happen, if it will lose 1 electron, it will gain the most stable oxidation state. But 3d3 is also a stable oxidation state in which 3 electrons remains in the lower energy level of d orbital. So 3d3, this is also a stable state. Therefore, generally chromium lose 1 electron from s and another 2 electron from d. Therefore, most stable oxidation state for chromium is 3 plus, 3 positive. So, if we go for if we go on checking, we will see manganese, titanium, it will show the +4 oxidation state. What is the titanium electronic configuration? If you check, it will be 22. 22 means argon, and then argon 18. Then what is the next one? This is 4s2, and then titanium is 22. So it will be 20, and then 3d 2 electron. So we can understand that if it will lose 2 electron from s and another 2 electron from d, then it will gain the most stable configuration of argon. Therefore, it will definitely lose 2 electron, and thus it has a more stable oxidation state +4. Okay, so there, if suppose I am giving you that titanium is in the +2 state, it will act as a reducing agent or oxidizing agent. Your answer will be, as they are having a high tendency to become +4 oxidation state, so it will lose 2 electron and it will become T4 plus, titanium 4 plus. So it will be, as it is releasing electron, it is oxidized. It is oxidized, that means it will reduce other one. So it can act as a very good reducing agent. So Ti2 plus will be acting as a reducing agent then. So this type of question also comes. Another oxidation state for the manganese. What will be the oxidation state for manganese? If we check, manganese 25, so argon 18, and then 4s2 3d5. So we can understand +2 is the most stable oxidation state for manganese, +2. If it will release 2 electron from 4s, it will become stable one. But the thing is, what it can also lose, if it can lose 5 electron, then also it will gain the most stable state. Therefore, manganese can show from +2 to +7, all oxidation state can be possible for manganese. Manganese can show +7 oxidation state even. Okay, so +5. Vanadium, if you check, vanadium 23. So after titanium, vanadium, so you can understand titanium electronic configuration, I said 4s2 3d2, and vanadium it will be 4s2 3d3. So what will be the how many number of electron it wants to lose? If it will lose 5 electron, 2 and another 3 electron from d, it will gain +5 oxidation state. So for the vanadium, +5 oxidation state is more stable state, +5 oxidation state. Okay, So these are the main basic things you need to understand in the oxidation states of the D block element. Another question also comes that copper, I said you with previous video that copper plus and copper 2 plus, if you check copper plus oxidation state is electronic configuration is more stable than the copper 2 plus, but actually reduction potential, if you consider, you will see that copper plus, once it is reduced, what is their reduction potential? It is more, means it is larger value, and if copper 2 plus will be reduced, its reduction potential is zero reduction, this value will be lesser. So as it is having the lesser value of reduction potential, so which one will have the higher tendency to be reduced? Copper plus. As copper plus has higher tendency to be reduced to become copper, therefore copper 2 plus is more stable than copper plus. Therefore generally we are saying that the maximum substances we are getting, which is in which we are seeing the oxidation state of copper is +2. Okay, so these are the main oxidation states of the D block elements, and few conceptual question also may come that whether it is oxidizing agent or reducing agent. Always remember, any substance which is having their most stable oxidation state, they always try to reach that particular oxidation states. Okay, so on the basis of that, the explanation can be done as it is a reducing agent or whether it is an oxidizing agent. So on the basis of that oxidation, as we are studying now oxidation state, so A block elements oxidation state also we can little bit discuss. So what are the A block elements general configuration? If you see, the general configuration is n minus 2 f1 to 14. That means f orbital can have may have 1 electron to 14 electron, any number of electrons it may have, and then penultimate shell, that is D shell, will contain mostly 0 electrons or sometimes 1 electron, and then after filling up 1 electron in the D, then electron starts coming in the f orbital. This is the F block elements general configuration. And firstly, the NS will be filled up by 2 electron, then 1 electron will come in the D, and after that the F electron starts filling. But the thing is what, this is D orbital is penultimate shell, and before penultimate shell the shell which is n minus 2 shell, this F orbital will be filled up. This is the thing according to energy level, and most of the cases, as it will lose 2 electron and 1 electron from D, it will gain the stable oxidation state. So most of the common oxidation state of the F block element is +3, and suppose what europium, we can represent europium as EU. Okay, electron atomic number is 63, europium atomic number, and if you see the electronic configuration, xenon, and then it is 6s2, then 5d0 and 4f7. As it will lose 2 electron, then it will gain half fill stability, therefore its oxidation state will be +2. Similarly, not only europium, we can see that if any substance, any element, it will gain, or any atom we can say, if it will gain the F7 stability or F0 stability, okay, or F14, this one F0 electronic configuration, or F14 or F7, if it will gain this type of electronic configuration after losing electron, then how many electron it will lose? This one will be their most stable oxidation state. As for example, europium 2 plus, as it will lose 2 electron, it will gain the F14, F17, F7 half fill stability, therefore its oxidation state is +2. Similarly, if we are telling about ytterbium, ytterbium is like it is YB. Okay, so its atomic number is 70. If you see, then it will be xenon, then 4f14. Okay, 4f14 means 5d0 and 6s2 was there, but if it will lose 2 electron from 4s, as D is having 0 electron. So it will gain what? 4f14 stability. So it will lose 2 electron to gain that stability. Therefore, ytterbium also means ytterbium also shows +2 stable state. And another one is what? Lutetium. If you are lutetium is another, I will show you one thing. And another one is, suppose F0. F0 is what? If cerium 4 plus, if we are seeing cerium 4 plus. Okay, so cerium 4 plus, if you will check, cerium atomic number is 58. So its electronic configuration will be xenon, then 4f2, sorry, 4f2, this one. Okay, xenon 4f2, 5d 0 and 6s2. So we can understand it will lose 2 electron from s and 2 electron from f. Then it will gain what? 4f0 configuration, stable state configuration. Therefore, it will gain the xenon stable configuration. Therefore, it will lose 4 electron and its most stable oxidation state is +4 state. So this, according to the different condition, it will show generally the oxidation state, but most of the stable oxidation state is +3. Okay, another thing is what? In this F block elements, we need to understand that I said you already that 3D and 4D series, they are having the similar 4D and 5D, they are having the similar or almost same atomic radii due to the lanthanoid contraction. In this lanthanoid contraction is what? First of all, lanthanum series. This starts with the lanthanum. Therefore, it actually, the series is named as lanthanoids. Okay. Now, lanthanoids is having what? They are F block elements, and we are seeing what in this lanthanoid series, that due to the, why there's contraction means what? As we are expecting that their size will be increasing as shells are added, but it's not increasing that much. What is the reason behind that? As the electrons are entering in the f orbital, and if electron shielding effect is very poor, therefore they are having what? Very less screening. They could not screen the nuclear charge on the outermost shell electron. Therefore, the attraction increases, the size decreases. So, this type of decrease or contraction in size is called the lanthanoid contraction, according to the name of the lanthanum. So, what are the main sequences of the lanthanoid contraction? These are the last topic of your syllabus this year. Lanthanoid contraction sequence is, firstly, you will see what? First thing, lanthanoid contraction sequence, that they could not be separated out. All the lanthanoids, as their sizes are similar, so therefore their so many chemical properties are also similar. So we could not separate out easily lanthanoids. We could not separate out the compounds easily. Okay. Another thing is what? For I already said that they are having the similar size. What is the reason behind that? This is only due to the lanthanoid contraction. Their size are almost similar, especially 4D and 5D series elements. And another sequence is generally the lanthanum to lutetium. If you go for means, you will see what? The size decreases as we go means along a period. What? From left to right, the size always decreases. So lanthanum to lutetium size decreases. As the size decreases, their covalent character increases. So lanthanum hydroxide and lutetium hydroxide, if you go, you will see lanthanum hydroxide is most basic, whereas as lutetium hydroxide is covalent in character, therefore least basic. Okay, so this question also comes, lanthanum hydroxide and lutetium hydroxide. I said you oxidation state is in mainly +3 oxidation state. So lanthanum hydroxide and lutetium hydroxide, which one is more basic? You will say this one. What is the reason behind that? Because this is size of the lutetium is lesser than lanthanum, therefore lutetium hydroxide is more covalent in nature, therefore less basic, means less basic. So no more today, because our syllabus is finished. This video, if you have any doubt you can ask me, but first go through the chapter and then do the important questions. Thank you class.